Hi everyone. So this is the sixth session of writing a Lisp in Python. So I set up the environment. And last time I think I took too much time explaining how the code was working, and I wasn't writing code fast enough. So this time I'm going to try to be faster. So we stopped at the interpreter, where we started implementing the compute function to evaluate Lisp defined or Python defined functions. We also did the eval function for the simple data types and symbols. We didn't implement recursive evaluation. And we defined in the built-ins a global environment with a few helpers to define built-ins. So this time I'm going to try to finish the interpreter and implement some more tests to make sure that everything works. So this part is probably, yeah, this is a duplicate. I'm going to remove that. So in this part, the compute function must deconstruct the function, the Lisp function, which is defined as a list of a parameter list, a body, and a function environment. So this is a manual unpacking of the function object of the Lisp of the list that describes a Lisp function. And to call these functions, I need to use the cell module. Okay, so the Lisp body is going to be evaluated inside the closure environment and not inside the parent scope, the parent environment at runtime. I'm going to iterate over the S expressions in the body, but since the body is a Lisp list, I need to iterate with a while loop. I also need to prepare the default return value. So in common Lisp, a function that does not return anything is a function that returns nil by default. I don't think that's the case in Scheme or Guile. So if I define a function that does not return anything, so if I try to, for example, display a string, the display function does not return nil. It returns something that is not a value, kind of like none in Python. In Python, a function that does not return anything is a function that returns none. And in common Lisp, functions return nil by default, so I'm going to consider that a function should return nil unless it evaluates something that something that is not nil. So this is the default return value that would be returned if nothing else is evaluated. And for each expression, I'm going to define the return value to be the result of evaluating the expression in the current environment. And the local environment is going to be a new environment that is created from the closure environment with parameters. So if, for example, let's say I am in Python, I define something in a function, and then I define a new function. No. If I define a function with a parameter, okay, so if I define a function with a closure and I return this function, okay, so this expression creates a new function that is called g with a closure to a in its local environment. That's why I can print a from the function after leaving f, and the parameter is defined alongside it is defined in a new local environment that is created during the function call, and the parameter overrides the closure. So if I define instead this parameter, local parameter has priority over the closure. So this is the behavior that I will implement. So I create a sub-environment of the closure environment, and in this environment I need to define all the parameters that are given here, and I need to bind them to these arguments to the parameter names that are defined in the function definition. So in order to, so I'm not sure if I want to, yeah, so if the number of parameters defined in the local, in the function definition and the parameters used when calling the functions are not the same length, I want to return an error to make sure that a function is not called with an incorrect number of parameter. But in order to use the special variable that is parameters in JavaScript, in JavaScript the parameters or arguments, I think it's arguments, is a special variable that contains a list of all the arguments when a function is called, and I want to use this in order to implement variadic function definitions. So I am not going to raise an error when something when the number of parameters is incorrect. Instead, I'm going to use the parameter list as an automated variable binding, and not as a part of the function signature. So if I have exhausted the parameters, the arguments, when iterating over the parameter list, then I am going to define the parameters left to nil. And I'm going to define a new binding in the local environment. So since parameters are symbols, they are defined as symbols. I'm going to use dot value to extract the Python string. And this line defines a new binding from argname being equal to argval. So this part is the function local environment definition, and this part is the evaluation of the forms in the function body. And if so I'm going to return result, because then the result variable is used for is a shared variable with the result of Python functions, and I process it if the function is actually a macro before returning the result. So this function should be completely implemented. I need to test it, but other than bugs, I think there is nothing left to add. Now that we have the compute function, we can implement the evaluation for functions or macros or whatever by simply computing the function with its arguments. In a Lisp function call, the first element in a function call is the function, but it's not a function object. It's usually a symbol that returns a function when evaluated. So I need to evaluate the symbol in order to get the function value. And at this point I'm going to add a type check to make sure that my code is not doing something weird. I'm going to define that the function should be a function. And the arguments could be an empty list in this case, for example, so a nil. The arguments could be nil, and I think this is fine here because I used while loops like this one to iterate over the functions, to iterate over the arguments. So the evaluate function is complete. Now the only thing left is the expand function, and I'm not going to implement it now, I think, because the evaluation rules are, because the evaluation order in a Lisp is that before being evaluated, a chunk of code is always expanded first when compiled. So the expand macro phase is always happening before execution, and I want to test, compute, and evaluate before adding more code. So I'm going to run the test that I already had to make sure they still work. Okay, perfect. Okay, so I still have the correct, so the code still executes without errors. So in order to try evaluating function calls with Lisp defined functions and test this chunk of code, I first need to define Lisp functions, which are going to be defined here in the built-ins with a define built-in. And before that, I need to verify that, to check that this function, this built-ins, execute correctly. So I'm not sure where to put the tests. I think I'm going to add a different file, maybe with PyTest. So first I'm going to move the tests that are already written, like this one for example. In order to install PyTest, so this test is using assertions to verify that lookup is working as intended. I'm not going to use print calls like before, because I want the tests to be automated and detect regressions instead of checking that the last current thing is still working. So this is the syntax for PyTest test. I just have to define a function that starts with the name test, and the function has to run as many assertions as I want. This is the format that I will use for all the tests of the project. And in order to install PyTest, I'm going to create a virtual environment. in the venv folder. And I can run pytest. So I got an import error because environment is not imported. I think I'm also going to have to import the lookup function, since that's what I'm using. And the tests validate. So here you have two items. So the pytest has found two unit tests, or two test functions to execute. So pytest goes through every Python module with a name that begins with test underscore. Same for functions, and since there are two functions, pytest is going to execute both of these functions. So if I want to fail a test, I just have to assert something that is not true, and pytest is going to report the place where the error happened, and it's going and also report that the test has failed. I'm going to import this test too. This is a test for the evaluate function. Since this test is incomplete, it's only evaluating simple values, and I don't want to rely on other code to make sure that the test validate. I'm going to make a different test just for the simple cases of compute and evaluate. I'm also going to define compute for native function, a test for computing native functions, and a test for evaluating complex values or function calls. And later I'm going to need a test for macro expansion. So this test may seem pretty useless, but the point of this test is that if I ever modify the lookup function, the test will tell me if I introduce a new bug. So this is something called a regression test. I'm not using it to specify to implement a specific protocol or or specification on the language runtime. I just want to avoid or detect new bugs. I'm going to keep the imports local. I know this is dirty code in Python to import inside the function, but this means that a function that a test that does not rely on the interpreter, for example, will still be able to execute properly as long as I'm not importing everything at once. For this test, for this loop, I can't keep it as a loop because I'm not going to print it, I'm going to hardcode the expected result. Okay, so I have translated the for loop into three assertions. Okay. What? I'm not sure what this means. I think Python. I always thought Python would allow any type of import in any place. Oh, okay. I think I know. It's because Python precompiles the Python code into bytecode before execution. So I think the problem is that Python, when defining this function, cannot get the list of symbols defined inside. And so if I do, for example, if I define a new value like x for example, or result, Python cannot know if this value is already defined by the import or not, I think. So I'm going to type the import manually. I think I got the name wrong. It's int type, okay. So the test is valid. I can remove it from here, which I already did. And now I need to test that the built-ins can be called from the global environment as functions can be computed. The calls can be computed. So I need to test that the code can be computed and that the lookup of the global definition works. So I'm going to start with no. So I just need to import the function. I'm not going to include the lookup because this is part of the evaluation test, of the eval test. And this test is doesn't really do anything new compared to this test. So I'm going to remove this test and write this one. I think these functions are probably not the best to use in a test because I plan to eventually replace toString with a dynamic lookup to toString here to the Lisp function, and this may break this test later. So I'm going to use something like maybe no, it's okay because it's a string. So I can use represent, for example, or toString in this case because the return value because there is no recursion, so the code is not going to change even if I replace this by a dynamic lookup. And I also need to test alternative function types like macros and special functions. I'm going to define an environment instead of evaluating the string parameter. I'm going to use this assert false statement to get the output, because if I don't have this line, if the tests are considered okay, I'm not going to get any output. Okay, so first, this is represent is a Python function, and I need to create the wrapper over it, or I can reuse the wrapper that already exists. So apparently I didn't define a represent function in the global environment. This is the current state of the global environment after importing it. So I get a parent scope, which is incorrect. This is incorrect because there is no parent scope to the global environment. Oh, okay. It's because the parent is nil. The parent is not known. It's actually defined to be a Lisp value, so this is okay. The current scope is itself, and there is a name entry. I'm not sure what this represents. Okay, this is the problem. So every time I define a new built-in, instead of setting the name to the function, it's setting name as the name. Okay, now this is better. I get all the expected bindings. Function object has no attribute type. Sorry. So, if I'm not wrong, the function object is always defined as a wrapper over another value. So the value always has so the value of the function inside the console always has a wrapper value over its content. And the error that I get is that this here, the native function or the Lisp function, which is defined as this, does not have a type attribute, which is not correct. I'm going to rely on the toString and represent functions to help me debug the state of the program. Since it's been a long time since I last used them, I implemented many types that do not have an implementation, as you can see. So I need to implement them one by one. I just wrote a conversion to. I just wrote a loop to convert every value inside the hash table to a pre-printed representation. This is not. I'm not going to follow the usual constraint that any Lisp value is represented as a Lisp literal. So I'm not going to. I'm just going to create a Python dictionary, basically. This is a temporary code just to help me debug the environment. For unique values, I think every unique value is named with the label, so I'm just returning the label. Yeah, I need to return a value. Action recursion. This is weird. Oh yeah, because the environment is recursive. I'm not sure how to fix this. I could make a different type just for the environment, where an environment has a specific Python implementation that takes care of the recursive references, and this would allow me to implement representation differently from other hash tables. I'm going to implement a quick underj fix. So if I'm going to add a special rule for this entry. Yeah, so I'm just detecting the current scope loop and returning, skipping this key if there is a loop. Then I need to print functions. This is a very quick and dirty implementation. So in this case, I hope that printing the Lisp defined values will work out of the box, and I can just implement printing native Python functions. I just want to do this as fast as possible in order to go back to debugging this situation. Function object has no attribute type. So I get back to the same error. So the problem is that this here seems to be a Python function and not a Lisp value like defined here. I'm not sure why. But this seems to be the core of the issue. So I'm going to try to find which function is like that. Maybe the code that creates this problem is here. Oh, yeah. No, this is not the problem. This could be the problem because it's the same name. So maybe, yeah, okay, it's not even the same. I just wrote the wrong code. Okay, now it works. So the problem was that I was putting this as instead of this in the value wrapper. I'm still going to implement the representation of native functions. This should not be possible. There is no type, there is no function type, I think. There is no type function, just native function. Okay, so this type is already implemented in represent. I have the type. Okay, I found the issue. I forgot to return. Okay, so this representation actually works. So I can verify that the parent scope is nil, which is correct since this is a global scope. The toString function is computed after evaluating the parameters. This is correct for a function, and this matches the Python function named toString. Same for represent and for inspect. And quote does not evaluate its parameters, or its single parameter, and this is perfect. With this I can inspect the state of the environment, of any environment, at any point in the program. So now I can get back to this problem. So the test compute. So the compute call is what creates the error. So this is a bug in compute and not in the test. This is what I was looking for. Great. Native built-ins that represent. Okay, so I'm using the represent function as a test function, and apparently it's because I used this, but I didn't. Oh yeah, that's the problem. I need to convert this Lisp list into a Python iterable. I think I didn't implement this. I could implement it in Python, but I want to avoid relying too much on Lisp to Python conversions, type conversions. In this case, I don't think it can be avoided, because Python does not accept Lisp lists as arguments. I could implement it in the decorator. So here. In define global. So in the interpreter, the function is called with the argument list as a simple Lisp list, and I'm going to have to unwrap the list. I think I should implement Lisp to Python, Lisp list to Python list conversion function, but I don't want to abuse it. I already did it in past implementations of this project, and I ended up always relying on list to cells and cell to list conversions. So I want to avoid it this time. Perfect. So the compute function executes correctly, but as I said earlier, I can't see the results because pytests hides the output of every test function unless the test has failed. So if I do this, then I can get this result, which I would like to represent, and that's about what I expected. So I'm going to write my assertions. And now I can be sure that if I try to compute a native call to represent with an argument list that contains the symbol that is evaluated to its value, because every parameter is evaluated by the compute function, then I can get the results to be the pretty printed the literal representation of the test string, which is a test with quotes around the word. So this code relies on symbol lookup. So when I compute the function, I have to send an environment so that parameters can be evaluated in that environment. So this code cannot work without this code. So if this code doesn't work, this means this doesn't work either. So the tests are sequential. This must work for this to work, this must work for this to work, and etc. I'm going to write it as a documentation. I think we did enough progress for today. We finished implemented the compute and the evaluate function. We added more pretty print types, and we actually computed a function call, which is a nice step. And the next goals will be to finish implementing all of this. So for example, I could test macros or special values with quote, for example, and I need to implement the define functions or define or whatever to implement Lisp functions defined in Lisp. And for that I will keep using this source directory and implement more source code. I'm going to output to generate the list of requirements that are used for this project in the virtual environment. Technically, I only use PyTest, but Valve has a self-description command called freeze to describe all of its current versions of dependencies and installed packages. I'm going to add the requirements to this project, and I'm going to add the environment to the gitignore file. And I also need to review the to-do file. I'm going to do it next time, I think, or before next time, and that's it.